Hello and welcome to today's session, Processing IoT Data and Serving AI ML Models with OpenShift Serverless. My name is Arvin Schneider. I'm Tech Marketing Manager in the Hybrid Platforms Business Unit at Red Hat, and my focus is on serverless, service mesh, creating solution patterns, and in general OpenShift topics. So today, just briefly, OpenShift Serverless consists of three main components, each having its own distinct responsibilities. Knative Serving is one for deployment and auto-scaling of applications. Knative Eventing is an infrastructure for consuming and producing events and providing you with capabilities for event-driven applications. And then there is Knative Functions, which is kind of a simpler approach to cloud-native development. It lets your developers focus on just implementing the function and offloading all the other details to the underlying platform. So now let's have a look at the demo environment. This is the high-level architecture of our demo today. It is a solution pattern called the Red Hat Connected Vehicle Architecture. So we see kind of three different edge tiers. We have on the left side our actual edge tier. We have a near edge, the regional IoT cloud environments, and we have our core data center, which is our central IoT cloud environment. On the left side, we have the vehicles. These are Quarkus applications, which are simulating vehicles which are driving from a start to a destination endpoint. And while driving, they're sending sensor and telemetry data to the regional IoT cloud environment. There is a connectivity stack, which is called Drogue IoT. I use this project. It is also an upstream IoT project. I use it as the connectivity stack to onboard vehicles and also use it for communicating from the vehicles to the regional cloud environments and also the way back. So the data coming from the vehicles is stored in the central Kafka of the regional IoT cloud environment. So we have also some integration components running in the regional IoT cloud environment. There is a distributed in-memory cache. There is an over-the-air update server and a bunch of Knative services already running there. What we want to do in this demo is we want to do some machine learning. Specifically, we want to predict road conditions for our vehicles, right? And we use the sensor data. And in the demo, we will forward the data coming from the Kafka and from a Knative broker. From the regional cloud, we will forward this data to the central cloud environment, to a Knative broker. And there we store it in the data lake, so in S3. Then in the central cloud environment, we use Red Hat OpenShift AI. This is our MLOps platform. We use this to train our model, and then we trigger a DevSecOps pipeline. So basically, we want to create a secure container image that also contains our machine learning model. And then we deploy this to the regional IoT cloud environment. So basically, this is then our model inference server, and we also implemented as a Knative service. So it can scale to 0 only when a request from the vehicle comes to the road condition service. It will scale up, right? So we can serve it as a Knative service. That's kind of the high-level architecture. In the next slide, let us just zoom into the Drogue IoT connectivity stack that you get a better understanding how this works, and then we jump into the demo part. So zooming into the just Drogue connectivity stack. Again, we have on the left side our vehicles, we have on the right side our business applications. And the box in the middle is kind of the architecture of Drogue IoT. We have endpoints, which are the device-facing protocols and protocol adapters. You see there is MQTT, there's CoAP, so some IoT-specific protocols. And all the data which is coming in, for example, over MQTT, will be transformed as cloud event and stored in Kafka. And from there, we offer the data also in various protocols to the business applications. And this part is called integrations, and there's also one Knative integration, and this is what we use in our demo. So the data coming in, transformed as cloud event, we will forward it as cloud event to a Knative broker, and from there we will process it in various ways, right? With Knative functions, serving, forwarding to another broker to do machine learning and so on. And Rogue IoT also has some, management components, but this is not really relevant right now. Yeah, that's basically all from the slide side. Now let us jump into the demo part and have a look first at the topology of a regional IoT cloud environment. So we're now logged into an OpenShift environment, and I have installed the regional IoT cloud environment in one of the namespaces called the Bobby car. Let's go to the workloads section, and here we have the topology view. So we see a bunch of containers and pods running here. Basically every blue circle represents a pod, and we have some things running here. You see, for example, here's the car simulator. This container is our vehicle simulation, and currently one pod is running, and this one pod is simulating 20 vehicles. Then there are other components like weather service. Here is our over-the-air update server, or we have a dashboard component running here, as well as some integration components, distributed in memory, cache, Kafka, etc. The big box in the middle here, this is basically our Drogue IoT connectivity stack. It is also microservice based, so all the endpoints integrations are individual microservices running here. There is also a dashboard component, and on the right side you see some serverless components running as well. So, and you see also pods are scaling up and down. So for example, here we have vehicles and they're driving through different zones, and whenever they drive into a zone or leave a zone, this will emit a zone change event, and there is this zone change service that handles these events, and now we see it scaling down to 0 and so on. So this is some of the existing serverless infrastructure here. Let us now have a look at the dashboard component. Clicking here at the URL of the dashboard, that should open our dashboard, and there is a map view. Let's go to this map and zoom in a little bit. First, you see these red circles here. These are basically the zones I'm talking about, right? If we create a new zone, this will trigger as an event. And also the vehicles here, you see the custom markers. So we have a bunch of vehicles driving. So whenever they enter or leave the zone, this will also create a zone change event, right? This is what we've just seen in the topology view. Now let us select one of the vehicles here. So select one of it and go to the car detail view of this vehicle. We have a cockpit view right now, and also we get the GPS data of the vehicle. Also, if there is street view data available, like here, you see the street view data. Yeah, so the vehicle is driving. We open now a heads-up display, and we see now for this vehicle the current speed, RPM, fuel consumption, and so on. There is also some other sensor data that is now sent over MQTT to the connectivity stack, and from there to the Kafka environment, right? So this is the data we want to use, that you see here, this data we want to use to do some machine learning. Now in the next step, we go back to the topology, and we will have a look at the data, what it looks like from a technical perspective, and therefore we log into our connectivity stack here. So there is a front end, a dashboard component, and if I click here, I open this dashboard. I can now log in to the dashboard. We have now an overview on the different sections here. So enable services, endpoints, integrations. We have our IoT application created here. So this is also multi-tenant. And this one application has several devices and configurations. So we can also look at the devices. So basically our 20 vehicles that are currently registered and sending data. And if we want to have a look at the data they're sending, we go to Tools, Spy, we can specify the application ID, and now we can start capturing events, basically the telemetry data which is coming from the vehicles. You see now we're capturing a bunch of events. Let's stop this, and we also have a look here. So these are basically JSON payloads that we get, different types. So for example, here's car, we have car metrics and so on. If we look at how this data looks like, so for example, here's the payload, we have engine data from the specific ID and with speed, RPM, etc. So this is the data we want to handle now. And first we want to forward the data to a Knative eventing broker. Then we want to pre-process the data, for example, and forward it to the central cloud environment to do our machine learning, right? So in the next step, we start with creating a Knative function to handle this data. We come back to the Stroke IoT project later to enable the Knative integration. But first, let us create a Knative function that handles this JSON payloads. So let's go ahead and create our Knative function. We use the CLI for that. So first we log into our OpenShift cluster and switch to the Bobbycar namespace. And then we use the function CLI, which is kind of a plugin for the Knative CLI. You see it here, kn-func version, so we can check the version of our func plugin. And we can also list available functions in the namespace, but there is nothing in there. We only have standard Knative services as of now. And let's see the languages or runtimes available to create our function. So you see we have Go, Node, Python, Quarkus, and so on. In our case, we'll use a Quarkus application. So we say Knative function create, we name it telemetry analyzer because we want to analyze or pre-process the telemetry data. We choose Quarkus as the language and cloud events as invocation type because we will get cloud events from our Stroke IoT environment, right? So let's create this project. Basically, we have now a standard Maven Java-based project. You can see kind of the structure. We can also have a look at it in the IDE. So we have now a telemetry analyzer folder with our functions project. You see there's a POM file with the dependencies and so on. There is actually our source code, very basic. So here's our function. It's just one function annotated with funky, and we get a cloud event as input, and we also return a cloud event in this case. We don't do anything here, but in reality, as a developer, I would now start to implement my logic here, right? So this is what I'm doing as a developer, and then there is a func YAML file here. And this func YAML file is also for the CLI. The CLI is reading it, and basically this is the configuration of the function. So with environment variables, build environments, and so on, the registry, runtime. So everything is configured in here. You can manually edit the func YAML file, or you can use the func CLI to edit it. But basically, it's a standard, in our case, Java project, right? So let's go back and start. So let's assume we have now implemented our logic, and then we can use, in our case, as mentioned, it is Quarkus. So I use the Quarkus CLI and start the application in dev mode. So I can just use my normal tooling locally for running, debugging the application. And now we're starting just the Quarkus application locally. Yeah, so the application is running, I can test it now, and so on. And if I'm done with local testing, I want to create a container image, and therefore I use the build subcommand. So this will now run an S2I build locally and will create a container image for me. And then I can test the container image locally. So the container image has been built. So you see it here, function image has been built, and now we can run our local container image by using the run subcommand. And you see our Quarkus application is running, and we can now also test the local container image by invoking the function. So I can go into the func project and just say Knative function invoke. So this will detect if a function is locally running right now. If not, it will try to access a remote function and invoke this one. So it is running, and this is our response. So basically the cloud event that we got back, it's just saying hello world. Yeah, so it's working, and this way we can now test our function locally, our container image with the function locally, and in the next step we want to deploy the function to our OpenShift cluster. So therefore we use the deploy subcommand, and we rebuild. In my case, I rebuild the function because I'm currently here on a Apple Silicon, and I have to use a different platform as a target. So this time I will rebuild the function for the target platform and will also deploy it to our OpenShift namespace. So let's do this. So the container image has been built, and now the function is being pushed to the OpenShift image registry. So it has been pushed, and now it's deploying the function to the cluster, and we're waiting for the Knative service to become ready. Actually, it is a Knative service which is running in the cluster, and we see perfect function is deployed, and here's our endpoint to the function. We can also check this in the topology view, and we see now here is our deployed function, which is called telemetry analyzer. And we can also invoke this remote function, so we can test it in the cluster with the CLI by also using Knative function invoke. And here we are. So this is now from the OpenShift environment. Now let me show you just another way to deploy or to create a Knative function. So let's assume we have committed our telemetry analyzer project, and pushed it to a Git repository. So our function is now in Git, and I show you another way to deploy a function. We're going to the core data center OpenShift environment here. We have here also a namespace, which is called telemetry external, and there is a Knative broker, and we just have a camel K operator, but there's nothing in there right now, right? So we want later to forward all the telemetry data to this environment. So it's coming into this telemetry AI broker. And we want here to pre-process the data before, for example, uploading it to S3. So let us create here also a Knative function which is doing it, right? So we add to project. In the topology view, there is a create serverless function option to choose from. And now we select the Git repository. It's this one here, and the context here. There is a function called event recorder in the subdirectory. You see it has detected that it is a Java application. Basically, it's a Quarkus application. We can give the function a name, and we say this is the event recorder. So we want to record certain event types which are coming in here. So I can specify, all the other options and just say, okay, create. And now it will pull the source code, the function source code from the Git repository. And you see there is now a build running in OpenShift. The build is currently pending, but a build is now running. And this will create the function and deploy it in this namespace. So this is another way how you could deploy Knative functions in OpenShift. In the next step, we have now our function running, right? Going back to the regional IoT cloud, you see here the telemetry analyzer, but we don't have any data right here. So now in the next step, we have to forward the data from our Drogue IoT, all the telemetry data. We need to forward it to a broker, and then we want to process this data, for example, with our telemetry analyzer function. So in the next step, we need a new broker, and we need to forward the data from Drogue IoT to this broker, and then we can process it with Knative. So let's do this. Okay, so we're back in the CLI, and again switching to the right namespace. And we wanted to create a new broker. So we call this broker telemetry. So we can check the broker in the topology view. You see here is our newly created telemetry broker. So next step is to forward the Drogue IoT telemetry data as cloud events to our newly created broker. Therefore, I have to enable the Knative integration. So going back to the Drogue IoT dashboard, we are selecting our IoT application, which is named Bobbycar, and there is a configuration also in a YAML file, and here we can just paste this section in. So spec Knative, disable should be false, and we specify now the endpoint of the Knative broker. So this is our telemetry broker that we've just created. Save it, reload, all right. And going back to the topology view, we should have somewhere, you see it here, there is now an events Bobbycar deployment coming up. This is belonging to the Drogue IoT environment, and this is now sending all the data to our telemetry analyzer. So in the next step, we create a new Knative service. We just want to log out all the events coming in, right? So we have a new Knative service device logger. We also specify a max scale of 3 pods and a scale window. So let's create this Knative service. Okay, so there is now our device logger service available. It is right here. So we have the device logger here. We have our telemetry analyzer. So the services are up and running. So now we create a consuming configuration. So basically there's a trigger that we create, and we say the source is our telemetry broker, and we want to sync without any filter everything to the Knative service device logger. So basically all events which are coming to the telemetry broker will be forwarded to the device logger. Let's create it, and also going back to the topology view, this is also reflected here graphically. So we have now this subscription, and you see it is instantly scaling up. And we can now explore the events which are coming in, going to the logs, and you see now a bunch of events are coming in. Now let's say we want to also consume some events with our telemetry analyzer function. So we can now create a trigger for it, and we want to filter. We want to have attributes, so subject should be car. These are only the GPS events, right? So let's add this one here. And you see we have now also a trigger created, and our telemetry analyzer is scaling up. And this one will handle now just subject car events, right? Or one container is running. Let's see the log files here, and you see these are the cloud events from our application, from our telemetry analyzer, and subject is car. So we only get these event types and can handle them, right? All right, so actually we're forwarding the data now to the device logger and to our function. Perfect. The next step, we update now our device logger service just to show you some configuration options with Knative Serving. So we specify a different scaling. So we have a max scale of 5, and we switch to requests per second, and with a scale target of 1, which is we define it as 1 request per second. So let's update this one, and it will result in a new revision of our Knative service. So a new revision is coming up, and it handles each revision, or each pod handles 1 request per second, and we are here now with 4 pods running. Perfect. And in the next step, we can list the revisions. So you see the device logger has now a revision 2, and all of the traffic is going to the new revision. So we can now update our device logger service and split the traffic between the revisions. We're saying like 70% should go to revision 1 and 30% to revision 2. So I'll configure this one. This doesn't result in a new revision. It's just a configuration of traffic splitting, but it's also reflected in the graphical UI. So we see it here. So we have now the 2 revisions. 70% is going to the first one, 30% to the second one. So what we want to do actually is we want to forward the data, so the car metrics, that the data that we use for machine learning, we want to forward it to the core data center, right? Therefore, we also create a trigger and we filter for car metrics from our telemetry broker, and we specify as sync the external address of our Knative broker in the core data center, right? So to this telemetry AI broker. So here is now our function, and now we can also create a trigger to consume the data coming from here, right? And we don't filter anything, just add, and you see instantly it's coming up. All right, so the data is coming into our telemetry AI broker, and we pre-process the data with our event recorder. So in the next step, we want to upload the data to S3 and start with our machine learning. So, all right, we are now going to upload the data to S3. So the CamelK operator offers you integration capabilities that you can connect with your Knative infrastructure. In our case, we have, for example, event sources and event sinks available to use with our Knative functions. And this is exactly what we want to do right now. We go to our telemetry broker, we drag this arrow, and we want to use an event sync. So we want to add an event sync. And you see, as I've installed the CamelK operator, these are the event syncs available out of the box for me, right? There's a bunch more. So I can use it to connect external systems to my environment. And in our case, I want to use the AWS S3 sync. So we want to sync the event data, the metrics actually, to an S3 bucket. So we can select this one. I can do it here in the console graphically, create an event sync. Then I have to specify, the access key, the bucket name, and the region, and so on, and the credentials. The source will be our telemetry broker. And if I hit create, this will now, the CamelK operator is responsible to create a deployment. Actually, it's a Camelot binding. This is a simplified interface to create integration routes, right? And it creates this integration for me to, getting cloud events, transforming the data, and uploading it, in this case, to S3, right? So there's this integration component. And this integration component itself is deployed as a Knative service. So this is the graphical way, right? So we can use it. You can configure event sources and things graphically, but also you can apply YAML files, right? And this is what I'm going to do right here. I have this S3 upload Camelot binding here as a YAML file with all the right credentials, for AWS. So I just apply this one, going back, and you see we have now a Camelot binding here, AWS S3 sync, right? And this Camelot binding is now also a serverless application. So this is implemented as a Knative service and is now scaled up, and it should be uploading now the data coming into S3. We can check this in our AWS console. I'm in the bucket telemetry Bobby car. Let's start here. So this has been also created by the Camelot binding. So this new bucket, and we should see a bunch of files in there. You see it here. Right, so we have all the files which are uploaded to our S3 bucket. Perfect. Now we have all the data we need, right? We've used Apache Camel K to do the actual upload and integrate with AWS in this case. And now we have the data in S3, and in the next step we'll start with our machine learning process. We're in the OpenShift environment of the core data center, and here is OpenShift AI installed. So we open the OpenShift AI dashboard. So this is our MLOps platform. We see that Jupyter notebooks are enabled. So there's different tooling and applications available to do machine learning projects like IBM Watson, Jupyter notebooks, and so on. We have a data science project. In our case, we want to predict road conditions. So we have a road classification service, and each of the data science projects consists of several components. So there is our workbench, we have an IDE, in our case it's a standard data science notebook, so it's a Jupyter notebook, and there are several packages also installed, like Boto3, which is the AWS SDK for Python, there is Pandas, and so on. So things that we use for machine learning. And also I have configured a cluster storage, so basically it's a persistent volume claim to hold all the data for my machine learning project, and we've also specified the data connection to our S3 bucket. This will be, so the credentials will be injected into our IDE container image as environment variables, and we can also configure then further, pipelines or model servers to serve our actual models. In our case, we're doing it differently. We want to deploy our model as a Python application as a Knative service. So, but first let us have a look at the IDE. So we open the Jupyter notebook environment. So here we are. This is our machine learning project. We have a few files in here. Actually, here is our data. So this is a CSV file. This is the training data we use to do our machine learning with certain sensor data in here. We've uploaded everything to S3, so we can now, for example, download the data, convert them into CSV files, and so on. We can do that right here. So for example, here is a Jupyter notebook to just as an example to list our S3 buckets. Let me restart this notebook. So we're not doing anything right here, just getting the environment variables or credentials from the env variables. We create a S3 connection, and we just list the buckets, and we see, okay, here is our telemetry bobby car bucket, and in there we have the files, right? So there is another playbook to download the files, convert the files, and so on. And then we have here our actual training job. So this notebook loads the CSV data, defines kind of the features. We split the data into training and test sets. This is something very typical in machine learning projects. We apply our algorithm. In this case, it's a random forest classifier. And then we run the prediction on the test data and test also the model accuracy. And at the end, we save the model to a file. So the result will be the model in this file. After each training job, we commit this project to the Git repository. So in this case, the binary file of our model is there included. Then we use a Python application that leverages the model and exposes REST endpoints. So there is this Python application. Basically, it's a Flask based application. We have route predictions, and there is a predict function, which is here, and this predict function loads the model and predicts the data based on the input we provide. So that's how it works. In the next step, we deploy this model as a Knative service to make it available for inference, right? So we're back in our regional IoT cloud environment. We go to projects. So we're creating a new project to deploy our machine learning application in there. So I call it Bobbycar AI Deploy. This is just an empty project. Okay, now we start adding to the project our application, our machine learning application. We import it from Git. So we're selecting the right project. So this is the road roughness condition project, and a builder image has been detected. So it's a Python application. This is absolutely fine for us. We can leave the things as they are. Just one important thing here is the resource type. So we want to deploy it as a serverless application. So we select serverless deployment. We could also create an OpenShift pipeline for it. But in this case, we just leave the defaults and hit the create button. And this will now just simply create our machine learning model, so our actual inference server, as a Knative service in this OpenShift environment. So we have an endpoint here, right? And currently the build is running, is pending, and then the build is running, and then we have a serverless model serving component available for our application. We have to wait until the build has finished. Now, as the build takes some time, I've already done this in a different namespace. I've called it Bobbycar AI. I've done exactly the same thing, and you see we have now our machine learning model as Knative Service. It is scaled to 0 currently, and now we can use it for inference in our business application. So in our case, it is in the vehicle, right? So I can go back to the dashboard, to the vehicles. Let me go to the dashboard component, go to the map view. Here we have our vehicles driving. We have now our machine learning inference server running. Let's select one of the vehicles and go to the car detail page. So here we are. So if I hit the cloud icon here, this will send a request to our AI/ML inference server, as well as to a weather service, and will get the data from both to aggregate the data and make a decision which assistance systems we want to enable in this vehicle. So you see here, there's the road classification result, the prediction we got for the current position of the road, and the current weather condition for our geo position. And if we go back to the topology view, you see it was scaling up, right? It's again scaling down to 0. We can just click again the cloud icon. Yeah, and we see here, by hitting the cloud icon, the AI/ML pod is scaled up and is serving the request, and we have the result here in our dashboard, right? So this way we have created, we've used the data coming from the vehicles to train a machine learning model. We used the regional IoT cloud environment. We forwarded the data to a central cloud environment, uploaded it to S3. We used OpenShift AI to do machine learning and to create a AI/ML model that we use for inference. We've created a container image of this model, deployed it into the regional cloud environment, and now we're using the inference endpoint from our vehicle, so from our business application. Yeah, that's it for today, and I hope it was helpful. This was kind of an end-to-end scenario showing, all different aspects of Knative. So we've seen Knative Serving, Knative Function, Knative Eventing, as well as the things we can do with CamelK in the context of Knative. In this more or less real-world scenario. Hope you had fun, and see you next time.